Yeah, absolutely. Scott and Joel, for the next Vibracore, could we use one with the standard core capture, please?
The
standard
original?
aperture, the original. And on recovery, can we lift it out and just close the gate? That's what we did the other day.
Yep.
And then press it against the gate,
That's
so
what we
to
have to
minimise loss. Because the sandy one we had the other day, that's what we did, and it recovered better. At least we didn't lose so much.
Cool.
Because if it's pouring out, it's obviously going to pour out as it's being extracted as well.
Okay.
Yeah. So just say when you're ready. Good to go now. Hello and welcome to the live stream on the Falcor 2. You're watching the ROV Sebastian here, and our next dive on our expedition in southern Chile. So welcome again to those who've joined, to anyone who's new to this, and to those who have joined us on previous dives on this expedition. My name's Dr. Seb Watt. I'm one of the scientists on this project. I've got behind me various other members of the team, and we're all making observations on this dive, keeping notes, and we're going to be talking to you about what we're doing today. Now, you've joined slightly sort of late into the dive today. We've already done our usual sampling sequence. For those who've seen this before, we start off with some water samples at the seafloor, then we've collected some push cores to get that shallow sediment at the seabed, and we're just moving on to the vibracoring, and we've just successfully recovered the first of those vibracores. We are in southern Chile for this dive, so this is an expedition in which we're exploring the volcanic history of the region, and specifically the impacts of volcanic events on the marine environment. There's one particular event that we have been focusing on, which is an eruption at a volcano called Chaiten, which is a volcano situated in northern Patagonia, in Chile. So we're in southern Chile, a few kilometres off the coastline, and this site here, if we looked out of the window, we could see the town of Chaiten in the near distance. So through this project so far, we've been targeting sites affected, or that we think were affected by the Chaiten eruption, and we've been piecing together, along with our other data sets with geophysical data, seafloor mapping, and our seafloor samples, a picture of the impacts of the Chaiten eruption in the marine environment. We want to understand how the eruption affected ecosystems, how the sediments that were transported into the sea by the eruption were dispersed, how far they reached, what their thickness and distribution is. And that will help us understand first how the marine environment responds to and is impacted by a major volcanic disturbance. And it also potentially provides a route by which we can go deeper into the past to understand previous events that were similar to the Chaiten 2008 eruption. Now, the volcanic materials that we're trying to track were not deposited directly by the volcano into the marine environment. They were actually transported through river systems that re-transported this volcanic sediment in the days after the eruption. So this eruption was a highly explosive event, what we refer to as an explosive volcanic eruption, and it was a significant event in this region. So it occurred at a volcano that was very little known before 2008, a volcano called Chaiten, and occurred without any recognised warning in May 2008, when a large eruption column ascended into the atmosphere at the start of this eruption to a height of around 15 to 20 kilometres. So this started very rapidly with intense explosive behaviour, and what's typical of these large explosive eruptions is that these events generate large volumes of fine volcanic particles, what we call volcanic ash, alongside slightly coarser fragments. So collectively we would refer to these as tephra. And depending on the grain size and the wind speed and the wind direction, these materials will be dispersed following an explosive eruption, and they will settle back towards the land surface, with the finer particles travelling the furthest and the coarser particles settling more rapidly. The consequences of this event were far-reaching. Ash reached right across Argentina, right over to the Atlantic as well, But around Chaiten volcano itself, there were large volumes, thicknesses of 10 centimetres or more across much of the local hillsides of this volcanic material deposited following the eruption. And this is a wet region, it's got steep topography, so very rapidly heavy rainfall remobilised all that loose sediment that had been blanketing the landscape, a bit like snowfall, and it carried it down into the local river systems, and this overwhelmed the capacity of those river systems. So this sort of slurry of volcanic sediment and water was transported down these rivers, and when those flows slowed as they reached the coastline, they spilled out over the river channels, they inundated the surrounding landscape, they built out the coastline, creating a new delta in the aftermath of this event. And this had major impacts in the region, particularly in the town of Chaiten, which was at the foot of one of these rivers, a river called the Blanco River. Chaiten town was entirely evacuated, and it took a number of years before it was resettled and rebuilt. So Chaiten town is now rebuilt, and we actually met some of the population of Chaiten, particularly several school groups, a few days ago. We had several school groups visiting the ship to learn about a really exciting part of the project, to be able to meet and to work with and discuss the science that we're doing with those school groups. So the event, the Chaiten eruption, has been well studied on land, and its sort of impacts have been well studied, but what hasn't really been studied before is what happened to all that volcanic material that entered the ocean at the coastline, and what impact that had on the marine environment. So that's what we're studying here. And this dive site is probably the last one actually in the area near to Chaiten. We're going to be moving slightly further away overnight, continuing to map south, and to understand the sort of more distant sediment transport routes through this region. So this final site has been chosen to sort of try to track the ash deposits south of Chaiten. We've had a couple of dive sites in recent days where we've been able to identify the deposits from this event, and this is a slightly more distant site, so we'll only really know when we bring these cores back onto the ship if we've recovered the indicators of that particular eruption, and of course if the cores go deep enough we may find evidence of earlier events as well. So I can't see the chat at the minute, so I'm not sure if there's any questions, but what I'm going to do is pass over to others in the room who can talk a bit about some of the work that they've been doing on this project. Behind me I've got Alistair and Jacob, who are working on some of the logging of samples and geological observations. I've got Gianluca, who's making biological observations, and then I've got Keris and Anka, who are volcanologists and working on the team as well, and I'm going to pass over to them first, I think, to talk a bit about their work on this cruise.
Okay, thanks, Seb. So let's just put it over. So I'm a volcanologist. My name's Alistair. So I'm here as a scientist on board this cruise. I also work on explosive volcanism. I work primarily on tephra, this ash and other material which is generated from these eruptions. Normally doing large amounts of field work and looking at on-land records, and my background really is in trying to piece together the eruptive history of volcanoes and their longer-term eruptive history to see what they've done in the past and what they might do again in the future. And Keris as well, are you over there? You're just on the other side of the room, so yeah, you can hear me.
I'm Keris. I'm a PhD student based at the University of Birmingham, so I work with Seb. Volcanoes, specifically looking at their ash records, but also using archives from sort of different types of topographic maps to photos to eyewitness reports to build up an understanding of eruptive records through time, specifically looking at volcanoes that collapse. So when I say collapse, it's a really sort of massive scale landslide of an entire volcanic flank. So you really do some restructuring of the volcanic system, so I'm investigating what that does to the magma reservoir. And beside me I have Anka, who is another volcanologist. I don't know if you want to introduce yourself, Anka.
Hi, I'm Anka. I'm based in New Zealand. I'm a physical volcanologist as well, and I've worked on similar things as Kara's, looking at long-term eruption histories and long-term behavior of our big mountain volcanoes, our stratovolcanoes. So I've looked at sediment transfer from the volcano where the loose deposits were produced and then reworked afterwards in lahar deposits and transported further away. So I'm really interested to see how this extends into the marine environment here. But I've also worked on large volcano collapses and landslides that produce debris avalanches, especially at Mount Taranaki in New Zealand. I've recently returned to my original interest of explosive volcanism and the products that are produced during those eruptions, in particular pumice, which is a lightweight, porous material, very vesicular and abrasive, so it gets transported quite far. It can also float in our oceans, or it can get deposited on the seafloor. So we've found quite a bit of pumice on the seafloor, as well as in Chaiten, in the rivers and on the beaches there. So I'm really interested to see how that behaves underground.
Yeah, well, no?
Room, this is tricky actually. So I was just going to say that just on the screen that are happening at the moment, so we're just putting into the seabed the vibrocore. So these are these cylindrical tubes of aluminium which we vibrate and push down in terms of the sediment. It pushes any sediment on the outside away from it and aims to collect any sediment on the inside.
So Alistair, why are we using vibration? Why are we not just pushing them in?
Well, the vibration allows us to get deeper penetration. It allows us to get further down in terms of sediments. We are using these push cores as well, which we're collecting for the upper portion. So these push cores are working like almost like a straw, like collecting with some suction, collecting the upper portion of material. Whereas as we get deeper in terms of sediment layers, sediment properties change. Things might be coarser. They might be sandier, or they might have other layers coming in, like these ash layers, which have different properties to some of the other muds and things which are surrounding them. So it's going to allow a more precise and deeper penetration through that. Today we've also used, for the first time on this cruise, a gravity core. Shada, if you want to talk a little bit more about that as well, Kiris.
So the gravity core is kind of in its name. We're using gravity and the momentum that creates to push the core barrel into the sea floor. We don't do this using the ROV. It actually goes over the back end of the ship, or sometimes it goes over the side. But it's essentially a long drill, sort of a long core barrel with a core nose, which is sort of like a pointed part, and then a core capture. The core capture is there to sort of stop any sediments that have gone in to coming out again. So what we do is we sort of use the A-frame, which is sort of the winch at the back of the ship, lift it over the side of the ship and lower it towards the seafloor. We stop at around 40 to 50 metres off the seafloor, and this is to allow the core barrel to stop swinging, because it's really important that we go in directly straight into the seafloor, not at an angle, otherwise this can sort of cause problems for our stratigraphy. But then what we do is we have some weights also loaded on, and we use those to help drive the core barrel into the seafloor. So yeah, like Alistair said, we had our first one today. We brought it up just before we stopped for dinner, so we had about just over 1 metre worth of sediment, so perhaps not as much as we had anticipated, but it was our first try. We're going to try another one again later this evening. The idea is that we can collect up to 3 metres, giving us sort of a bit longer of a record than what the vibrocores are doing. But yeah, so hopefully we can keep you updated with that as we go.
Exactly, and so there's various different ways of collecting sediment and collecting cores. We have drilling as well. So drilling can be various different forms as well, but we often use rotational drilling, so this can get us even deeper. So different types of coring and drilling mechanisms can be changed for different types of sediments, for different types of recovery. I've worked on drill cores which have been through sediment cores which are down to 500 metres depth. So this is done in sections where you collect them in 1.5 metre barrels and liners, and then you drive down and cut through that rock and the sediment, and start again collecting at each different levels. So it's various different types of drilling and coring. The stuff that you're seeing here, this fibre core, is just one mechanism. This fibre core was developed just for this cruise. It wasn't part of the standard kit on Sebastian, so it's been really exciting to use this and to be getting some really cool cores from this as well. So when we pull the cores up, so obviously what you can see now is these vibrations, and it's pushing down, and we're making notes on the biology and anything else that we're seeing at the bottom of the ocean. But when we pull this material up, we essentially split this in half, and we end up with two semicircles of material. Today, I mean, we looked at some that we collected last night, and within that we had a really nice record of the Chaiten eruption recorded very near to the top, just below the surface, which is where we would expect to see it, as it's only 2008, so in geological terms it was 5 minutes ago.
So, as Alistair mentioned, we split them in half. That's not only to be able to sort of see what's happening internally, but we separate them into an archive half and a working half. That's really important. So we have the half that we are currently working on, logging, photographing, taking our subsamples from, so the bits that we want to use to go off and do further analysis. But it means that you leave an archive half completely untouched, which means that in the future, if we want to come back and look at sort of the untouched side of the core, or perhaps there's more forms of analysis that have been sort of created, or perhaps we didn't consider the first time, it means that we've got another set of records that we can go back to, and we can go back and use it without having to use the ones that's maybe completely depleted or contaminated. So when we are sampling from the core, we also don't sample directly from the sides or the bottom. That's because you can often get some contamination with sort of fluids and sediment moving inside the core barrel, so we only really want to sample the inner middle section, which means actually we don't have that much sediment to work with. So having that archive half available is really important for future work.
Yeah, exactly. Yeah, so the sort of process we have in the lab is that once we've got everything split and we've cleaned up the surface, as when we pull it apart, it always needs a little bit of a clean. We then start to describe and understand what materials we have in that core. So, for example, if I just use the example of the one I've just done, I've just been describing that core and making graphical logs through that core, so it's fresh in my mind. But we had a sort of very fine ash towards the top, which we're trying not to interpret too much at this stage. More further analysis, and when we're back in the labs and things, when we're off the ship, on the onshore side of all this work, which is will be done by various people and involve various institutions. We'll build up a bigger picture, but this is potentially some of these lahars which is coming in, and finer material that's settling out. As we get lower down, we see lots of sediments in between. We also had another volcanic eruption layer which was recorded. This was darker in colour, probably from a different volcanic source. Next door to Chaiten is a volcano called Minchinoawila, and we have colleagues on board who have also they're working for the Geological Survey here in Chile, and have worked on this volcano extensively, making new hazard maps for this. So I know the volcano very well, and their thoughts are that this might be related to a layer from there as well. So we can start to build up our idea with synthesizing records between the marine environment and on-land records as well. If anything's been dated and geologically dated on land, then we can also date them independently. In a marine environment, we can get these ages to see if they match, and build up a chronological study basically through these cores. We also do this through the marine life as well, which is I've got Jacob here sitting next to me. He's doing lots of logging. I've just handed him the sheets that I was writing, so I can talk a bit more. and he's really interested in some of the micro paleontological samples that are in these cores, like forams and diatoms and various other things with long names.
Yeah, I'd say that.
Silica flagellates and dinoflagellates and
Mostly diatoms.
So we've spoken a lot about the science, and a lot of those who join these calls, you'll know a lot about it. But I think maybe if we try and talk a bit more, perhaps what it means to be a scientist aboard these ships, sort of what life is like here. Alistair, can you tell me your favourite moment aboard this expedition on the Falcor?
That is a tough one, isn't it? Because
We had
so
some
many
pretty
favourite
nice.
moments.
Yeah.
Sorry.
We had some pretty nice ice cream for dinner today.
Oh, we did. Yeah. Apple and cashew nut ice cream. Yeah, so we tend to get ice creams on Sundays, don't we? And it's all homemade, I think, on board. And there's been some pretty funky flavours, but today was apple and cashew, which I've never had. Was it cashew? Or was it? It was cashew, wasn't it? Yeah, it was cashew.
Yeah, cashew.
Don't want to get my nuts mixed up. Yeah. How about you? Well, I guess that probably was yours, because you went straight to bringing up the ice cream.
I don't know, the gravity core was pretty cool. Nice to be doing gravity coring again.
Yeah. I don't know. I think there's loads of highlights, but I mean, I could go for something very cheesy and say, all the wonderful people and the scientists on around and something like that. But I'm not going to do that. I'm going to say that the chocolate drawer is pretty good. We have a chocolate drawer which is frequently topped up by some of the crew, and we have Snickers, Kit Kats, Milky Ways.
Some brand advertising there.
Oh. Yeah.
How about your cinema experience last night, Alistair?
Oh yeah. So we watched The Never-Ending Story, which to me did feel like it didn't have an end. It just went on forever and ever.
So to provide some context here, the RV Falcor 2 is named from a character within this film, which was a book.
A book by Michael Ende, a German author, and I grew up with that story, so watching the movie again after quite a long time brought back memories, some happy ones and some traumatizing ones. And of course we all wanted to ride on the Falcor, on the Luck Dragon, and that's what we're doing at the moment, kind of.
Kind of, yeah. It's similar sort of way, yeah. Yeah, the film was great. I'm not sure I fully understood what was going on, but I mean, it'd been a long shift, so maybe that's the reason why.
Well, maybe we get back to other favourite moments. I think my favourite moment was when we opened the core, where we first saw some volcanic ash, and that was definitely my favourite.
It's a very scientific
There was a lot.
moment.
There was a lot of excitement at that time.
Yeah, there was. Yeah.
Anchor also had the really exciting opportunity. So whilst we were having school children and local councillors visit, Anchor actually went on shore. They went to go have a look around the town of Chaiten, walk towards the museum that is now sort of shows how the consequences of these lahars going through Chaiten. But also to have a look at some of the rocks and the sediment that's still sort of within the basin and the delta that's feeding out to this marine environment, looking how this delta has sort of continued to extend and evolve through time. So we went out with another member of our team where they were able to fly a drone. So it's given us some really cool context for what we're seeing here in the marine side of things.
Anka, do you want to talk a bit about being on shore?
Yeah. So we went to a few sites on land just to really understand what the sediment is like that gets washed into the marine environment, and then trying to correlate what we're seeing here in terms of what particles and what grain sizes we find to what we see on land. And there were 3 really interesting sites. One site is up the river where we saw the lahar deposits, 3 metre thick, fine-grained, ash-rich deposits. That were quite surprising. I'm used to other kinds of lahar deposits that have big boulders in them, a lot of sand. but it kind of matches what we're seeing in the marine environment, which was really exciting. And then I traced the river down to the river mouth, where it built up a huge delta in the aftermath of the eruption from all the laharic material that came into the ocean. And that alternated between coarse grain and fine grain deposits, kind of a mix that we're seeing on the ocean floor as well. So we got to have a look at the particles from both areas and compare them, and try to put the pieces of the puzzle together, see how they all fit together, which is really cool.
Brilliant, yeah. No, that's fantastic. Well, we've just finished actually, because we were later starting this dive stream. So yeah. So thanks for everybody who's tuned in. Sorry it was a bit of a short one. We just had some technical issues with getting the live stream started. So I'm sure we want to hear more about ice cream flavours and being on shore and doing amazing field work and things like that. But for now, we'll sign out. There will be more of these dives soon. I mean, we're going to be collecting lots more material over the coming days, so do keep a lookout for when we're next streaming.
We'll
different perspective from everybody.
Yeah, we'll catch you in the next one.
Yeah, exactly. Yeah. Well, thanks for watching.
Like, I don't know why that's like